What happens when we multiply two integers? Is the outcome of that multiplication is an integer or something else? If the outcome is an integer, then we will say that the multiplication of two integers follows the closure property, just like it followed in the case of addition of integers and subtraction of integers. If you remember, we had discussed that. So let's take an example. Let's take two numbers. The number, suppose a is say -1, b is say -2. So these are integers, these are two negative integers. So if we multiply it, that is a times b, this will be -1 times -2. So since there are two negative integers and 2 is an even number, therefore your product will be a positive one, it will not be a negative one, and 1 times 2 will be 2. So a times b is 2. Now, is 2 an integer? Yes, 2 is an integer. Let's take one more example. Say here we took 2 negative, now it's time to take 2 positive. Say a is 3 and b is 2. So a times b will be 3 times 2. This will give you 6. Okay. Is 6 an integer? Of course 6 is an integer. Let's take one negative and one positive. So a is -4 and b is 2. So what's a times b? A times b is -4 times 2. Since there is only one negative integer, therefore this product will have minus sign, so minus, and then 4 times 2 is 8, so this will be 8. Is -8 an integer? Yes, -8 is an integer. What about a is 4 and b is -2? Okay, and here a was positive, b was negative. Here a is positive and b is negative. So a times b will be 4 times -2. Now since there is only one negative integer involved, therefore again this product will have minus sign, will be negative, and this will be -8. Again -8 here, -8 here. These both are negative integers. So it means that if we multiply two integers, doesn't matter whether they are positive or negative, the outcome will always be an integer. And therefore in general we can say that a times b, that is a times b, follows the closure property. It follows the closure property. It follows the closure property of multiplication. Or the multiplication of two integers in general is always closed under, two integers are always closed under multiplication. Okay. Suppose you have two integers, and integers are a and second integer is b. Second integer is b. If a times b is equal to b times a, okay, if we can say in general term that a times b is equal to b times a, and where a and b are integers, then we will say that the multiplication of two integers are commutative. Okay, they follow, two integers follow the commutativity of multiplication. Okay, the condition is a times b should be equal to b times a. And let's take an example. Let's take two numbers. Suppose you have a as, take some different color. So a is -3 and b is -6. So in this case a times b will be -3 times -6, right? Two negative integers, therefore the product will be positive and it will be 18. What about b times a? B times a will be -6 times -3. So this will give you again 18. So these two outcomes are equal. In case of a times b and in case of b times a, outcomes are equal. Let's take a is equal to 3 and b is equal to -6. What about this one? So in this case you have a times b. Let me take the same color, right, so that you don't get confused. A times b will be 3 times -6, and this will give you -18, because only one negative integer is involved here, and since 1 is an odd number, therefore you'll get a minus sign in your outcome of multiplication. And what about b times a? This will be -6 times 3. Again it will be -18. These two outcomes in the case of a times b and b times a are same. Therefore again, from these two examples we can say that in general a times b is equal to b times a, and therefore two integers are commutative under multiplication. That is, two integers follow the commutativity of multiplication. Suppose you have three integers a, b, c. These are three integers, and let's say a times b is grouped together and then times c, and it's a times, in the second condition it's a times b times c, where b and c are grouped together. If this first condition, where a and b are grouped together for multiplication, is equal to the second condition where b and c are grouped together, then we'll say that the multiplication of integers are associative in nature, or the integers follow associativity of multiplication. And let's take assign some values to these integers. These are some arbitrary integers. That is, let's say a is 1, b is 7, and c is 5. Let's say this is the condition. So if a and b are grouped together, this will be 1 times 7 and then 5. Sorry. And in this case, the second case is 1 times 7 times 5. So if you solve these, then this will be 1 times 7 times 5, and this will be 1 times 35. This will be 35 and this will be 35. So these two are equal. So it satisfies this condition. Now suppose a is -1, b is -2, and c is 8, simple 8. Okay? This is a, this is b, and this is c. Now check it for this one. So a times b will be -1 times -2 and then 8, and for this one it will be -1 times -2 times 8. If you solve these, then this will be two negative integers, therefore the outcome of this particular multiplication will be positive, and since 1 times 2 is 2, therefore 2 times 8, and here you have -1 times, here only one negative integer is involved, therefore this outcome of this product will be negative, and since 8 times 2 is 16, therefore it will be -16. This will give you 16 and this will give you 16. These two are equal. Once again, this condition gets satisfied. This condition gets satisfied. Therefore, multiplication of integers are always associative in nature. Whether they contain positive integer or they contain negative integers, doesn't matter. They'll always follow the associative nature. And in general, we can say that a times b grouped together times c is equal to A times B times C grouped together. Next one is distributivity of multiplication or addition. So what that means, suppose you have three integers, and integers are a, some arbitrary integers a, b and c, and suppose that it's a times b plus c. B and c are grouped together in multiplication. If a times b plus c is equal to a times b plus a times c, okay, so a times b plus a times c, then if this condition is satisfied, then we can say that integers follow distributivity of multiplication or addition. Why or addition? Because you have plus sign here, you have plus or addition sign here. And why distributivity of multiplication? That's a really tough twist to pronounce. Distributivity of multiplication, because you have multiplication sign here. So distributivity of multiplication or addition is due to this reason, that you have a multiplication sign and then you have this plus sign, and these are three integers, a, b and c are integers. If this condition gets satisfied, we have to check it, then we can say that integers follow distributivity of multiplication or addition. So let's take assign some values to a, b and c, and let's say a is -3, b is say 5, and c is say -8. I've taken all negative integers, I mean not even a single positive integer. So if you assign value here in the first one, that is this first condition, so this will become a times is -3 times, and then you have b is -5, then you have plus sign, and then c is -8. So this will become -3 times, this is -5 and plus, and you have a minus sign here, therefore this will be minus sign, and this is 8, this will be -3 times 8 minus 5 minus 8 will be -13, and this will be 39. Now it's time to solve this one. So this will be a times b will be -3 times -5 plus a times c will be -3 times -8. This will become -3 times -5 will be 15 plus -3 times -8 will be 24. This will give you 39, and therefore we can see that 39 here and 39 here, these two are equal, and this condition gets satisfied. You can assign some other values to a, b and c, and just check whether in every condition you are getting this same result, where this first condition, that is a times b plus c, is equal to a times b plus a times c. In this case, this condition got satisfied, and we can say that integers follow distributivity of multiplication or addition. What about subtraction? So here we had some addition. If this is minus sign, that is if a times b minus c is equal to a times b minus a times c. If this condition gets satisfied, then we can say that along with addition, with subtraction also, integers follow distributivity of multiplication. So assign some values. Let's say that a is -1, b is -5, and c is -6. So for this one, it will be -1 times -5, minus here, this minus here, and this is b is -5. Sorry, c is -6. This minus sign is this one, and this minus of the c, or value of c. So it will be -1 times -5, and say let's remove this bracket, and it's -5, minus and minus sign, this will become plus, this will be 6, this will be -1 times, this will become 1, this will be 1, and your answer will be -1. Solve for this one. So this will be a times b will be -1 times -5 minus -1 times -6. This will be 5 minus, in this case here you have -1 times -6 will be 6. So this is also coming equal to -1, and therefore we can say that -1 here and -1 here, both these values are equal, and this condition gets satisfied. Therefore, along with addition, integers follow distributivity of multiplication over subtraction too.